Hello class, today we're going to be taking a look at the quiz that we took on Elastic. Let's go ahead and get started. On the first question, we're asked to find how many zeros the polynomial function has. So just by looking at this graph, I want to see where the graph crosses the x-axis, because that's what our zeros are here. If I have a zero, that's the same thing as roots. It's the same thing as where the graph touches the x-axis. So if we go ahead and take a look at the graph, this happens 4 different times. We have 4 different roots. So that's why my answer here is 4. And then we want to see where those roots occur. So one of them happens at x equals -4. Another one happens at x equals -1. Here x is 0. And here x is 2. So the answer that matches all that is this one here. Okay, question 2. We want to find the degrees of these polynomials, identify the number of terms, and give the name based on the number of terms. We see that the highest degree here is 4. So the exponent that is the greatest, the biggest exponent is 4. That's why we say our degree is 4. And then we want to look at the number of terms. So remember, terms are always separated by a plus or a minus. There's a minus sign here and a plus sign here. So the 7x to the 4th, the 8x to the 3rd, and the 5 are 3 different terms because they're being separated by a plus or a minus. When we have 3 terms, that is a trinomial. Okay, on the next one, our degree is 5 because that's the highest exponent we have. And there are no pluses or minuses here, so there's only one term. And when there's one term, that is called a monomial. Last one, we want to look at our highest exponent, that's our degree. So that's going to be 2. There's a plus sign here, so I have 2 different terms here. And when we have 2 terms, that's a binomial. Okay, question 3. We want to find the solutions to the equation. So I'm going to take every term in parentheses here and make it equal 0. So x minus 7 equals 0, x plus 1 equals 0, x minus 9 equals 0. Then we can just solve. So we add 7 to both sides. That gets us x is equal to positive 7. We can subtract 1 from both sides. We get x equals -1. And lastly, add 9 to both sides. We get x equals 9. So I want to choose x equals 7, x equals -1, and x equals 9. Just like I found off to the side here. Question 4. We want to find the zeros of the function for the graph shown below. So remember, our zeros are where the graph touches the x-axis. So that happens here at x equals -2. That happens here at x equals 1. And that happens here at x equals 4. Note that our graph also touches the y-axis here, but we're not concerned about that. The roots are only related to the x-axis. So I only want the -2, the 1, and the 4, because those are x values. So we show that in our answer here, the 4, the 1, and the -2. Okay, this is going to be similar to another problem we've done. We want to take each term here and make it equal 0. So x minus 2 equals 0, x plus 1 equals 0, x minus 4 equals 0. We can add 2 to both sides. We get x equals 2. Subtract 1, we get x equals negative 1. And add 4, we get x equals 4. So we see our answers here. X equals 2, x equals negative 1, and x equals 4. Okay, question 6. A polynomial function contains the factors x, x minus 2, and x plus 5. Which graphs could represent the graph of this function? So here are our roots, our factors. X, x minus 2, and x plus 5. If we set this equal to 0, we can determine where the graph is going to touch the x-axis. So let's set x equal to 0, x minus 2 equal to 0, and x plus 5 equal to 0. Well, here we just get x is 0, here we get x is positive 2, and here we get x is negative 5. So I want to look for which one of these three graphs has those three roots. And it looks like this one's going to work because the graph crosses the x-axis at negative 5, 0, and positive 2. This one only has 2 roots, not the 3 roots that we found. And this one has a root of negative 2, and we were looking for positive 2. So it has to be this first one. Question 7. Which of the following is not a solution to the equation? So in order to answer this, it might be helpful to find out what is a solution. So let's make this equal 0. We would have x equals 0, x minus 3 equals 0, and x plus 4 equals 0. So we get our answers 0, positive 3, and negative 4. These all happen to be one of the choices, but we're looking for something that is not a solution. All of these are solutions, so it can't be any of them. Question 8. We want to factor the following expression. So when we're factoring something, we always want to look at the last number. Then we can make a list of everything that multiplies to get that last number. So 1 times 56, 2 and 28, let's see, 4 and 14, and then 7 and 8. From this list, I want the pair of numbers that's going to multiply to get negative 15. Well, I know 7 plus 8 gets me positive 15. To make it negative, I can just make both of these numbers negative. So our answer should be x minus 7 times x minus 8. Let's move on to question 9. What we're doing here is looking at the graph and determining the multiplicity of each root. So let's remind ourselves of our multiplicity. So this is the behavior of what happens to the graph as it crosses through the x-axis. So if we have an even multiplicity, that is when the graph bounces. So when it touches the x-axis, it's going to bounce here. When we have an odd multiplicity, there's 2 outcomes. It could either bend or go straight through. So it either goes straight through or it bends as it crosses the x-axis. So on this first root here, we notice that the graph touches the x-axis and then bounces up. So that has to be an even multiplicity. Here at this root, the graph crosses through without bouncing, so it has to be an odd multiplicity. And same thing here at this last root. It crosses through without bouncing, so it has to be odd. Question 10, I ended up making a little mistake, so if you got this one wrong, it doesn't count against you. But what happened was this should say negative 4 and this should say 3. So based on this function here, we want to find the zeros and the multiplicity. So our 0 here would be x is negative 4. And since we have that exponent of 5, the multiplicity is 5. Here our 0 is positive 3, and because of that exponent of 4, the multiplicity is 4. So once again, if we have odd multiplicity, we're going to end up bending. So 5 is odd. That's why we say the 0 bends there. And 4 is even, so that's why we say it's going to bounce. Last question, we have a polynomial, and it has 3 zeros. So x equals -1 has a multiplicity of 2. So whatever this is, whatever this 0 is, we know that it has to have an exponent of 2. Our 0 of x equals 2 has a multiplicity of 3. So this 0 will have to have an exponent of 3. And lastly, x equals 4 has a multiplicity of 1. So this, we could say it has an exponent of 1, but we don't have to write that. We could just leave it blank. So we're kind of working backwards here. If I have x equals -1, to turn that back into a factor, I can just kind of go backwards. So normally we would start with something like this and solve for x and get x equals -1. But really what we want to do here is just add 1 to both sides. So we get x plus 1 equals 0. And that ends up being our factor. So we can check our work. If I have x plus 1 equals 0, and I want to solve it, well, that's just going to be x equals -1, which is the 0 I was given. Let's keep going with this. If I have x equals 2, and I want to turn that back into a factor, I can just subtract 2 from both sides. So I have x minus 2, and then x equals 4. We're just going to have x minus 4. So we want to show the answer that has all 3 of these factors. We have x minus 2 to the 3rd right here, x plus 1 squared right here, and then x minus 4. So this answer gives the correct polynomial.